All right, permutations versus combinations. A permutation is going to be a scenario where repetition is not allowed. This will be the same for combination. The difference is, with permutations, order is important, and with combinations, it is not important. What we mean by repetition is if we're pulling things from a group, we can't use the same thing twice. So for instance, if we're trying to pick out someone to be president of our club, they can't be both president and vice president. We have to have separate things. There are some clue words. You might not always see them, but if you do see them, it's safe to assume we're in a permutation. These clue words are schedule, order, president, first place, or really any title that we give somebody. Chairman of a committee, any title that makes someone have more responsibility. Now, there are two ways that we can get an answer for a permutation. There's the formula I have listed here, or you can find the permutation button on your calculator. It's usually NPR, or it might be under the probability button, PROB, or you can Google where you might find how to type in a permutation on a calculator. So let's look at our problem. How many different ways could first, second, and third place finishers occur in a race with 6 runners competing? Well, we're picking winners, first place. So that's one of our clue words. So I know that it's a permutation. I know order is important in this because being in first place is a lot different from being in third place. First place gets a gold medal and third place only gets a bronze medal. I have 6 runners competing. Now N is going to be 6, my total sample. How many people are competing? N is always going to be my larger number. And R is going to be the smaller number, how many people I'm choosing. So my answer would look like this, 6P3, 6 permutation 3. You can type this in your calculator, or you can use the formula here. Remember the exclamation means factorial. 3 factorial is 3 times 2 times 1. So whatever the number is times everything less than it. There's also that button on your calculator as well. So N is 6, so I get 6 factorial divided by N minus R, 6 minus 3 factorial. That gives me 6 factorial divided by 3 factorial, or 120. We're looking for 120 for our answer. Now let's look at combinations. Again, in combinations, repetition is not allowed, so we can't choose the same thing twice. But this time, order is not important. Again, there's some clue words. They're not extensive. There might be combinations that are not on this list, but these are safe to assume we're in combinations. Set, group, sample, selection, and committee. We have our formula here, NCR. Again, you can find the button on your calculator or use the formula. The only difference is in the denominator, we now have a R factorial, so we have 2 terms. How many ways can a sample of 5 cell phones be selected from a shipment of 24 cell phones? So I have 24 as my N and 5 as my R, so 24C5. I do have to be careful when I'm typing this in my calculator because I have 2 terms on the bottom, so I've written that out. So in the numerator, I would have 24 factorial. On the denominator, I would have 5 factorial, and then 24 minus 5 factorial, which turns out to be 19 factorial. If you're going to type in your calculator in just one step, you're going to want to put parentheses around the denominator to make sure your calculator knows that both the 5 and the 19 are in the denominator. If you want to do in 2 steps, then this isn't necessary. If you're going to do 24 factorial, get an answer, and then figure out what the denominator is, and then divide. Sometimes that can be tricky, though, because factorials get large and the numerator could be too big for your calculator to process. So just be careful with the parentheses. Let's look at one more example. A security team visits 12 offices each night. How many different ways can the team order its visits? The word order right there tells me, okay, I'm in a permutation because order is important. So my work would be 12. It's a permutation. I'm visiting all 12 offices. So it's 12P12. So using the formula, again, you could use your calculator, the already programmed in calculator and not need the formula, but if we're going to use the formula, on the bottom I get 0 factorial. And just by definition, 0 factorial is 1. So it's really 12 factorial divided by 0 factorial, which is just 12 factorial. Another way to think about this problem is not even to use permutations. And with permutations, we have this option. Combinations, we're just stuck using the combination formula or the button on our calculator. So just to explain why it is just 12 factorial and why the 0 factorial turns into 1, if I'm thinking about how to order these visits each night, when I go to choose my first office, I have 12 choices. Well, once I go to that office, then there are 11 offices to choose from. Once I visit the next office, there are only 10 left that I haven't visited. So each time I'm going to decrease by 1. 12 times 11 times 10 times 9 times 8. And that's exactly what the factorial is. So you could work this problem 2 different ways. You could work it using the permutation formula or button on your calculator, or you could just work it as a factorial.